Hi, good afternoon, everyone. Welcome and thank you, everyone, for taking your time and attending our webinar today. My name is Sushain. I'm from Paramount's marketing team. We have here with us today Mr. Premchand Kurup, who is the CEO of Paramount Computer Systems, Mr. Jason Garbis, who is the Senior Vice President of Product Management from AppGate, and Mr. Amit Sharma, who is the Service Delivery Manager for Paramount, and who has been instrumental in deploying AppGate software-defined perimeter in the Middle East region. So these three experts will be discussing today on the advantages of deploying a zero trust network and how AppGate's software-defined perimeter can benefit your organization. And of course, we'll discuss on some use cases. So without further ado, I'll pass on the mic to the panelists. Hope you enjoy the webinar. Thank you.
Thanks, Sushan. Good afternoon to all our viewers, and thank you very much for being here with us this afternoon. In the last 2 decades that we've seen the transformation of what was called the internet security business. It was initially called internet security, then it moved into information security, then into cyber security, and now it's slowly transitioning into digital security. Now, during this time, the single largest change that I have seen is twofold. One is because of the onset of COVID and the huge work from home, when all of a sudden, from a scenario where we had just a very few remote workers, we are into a situation where almost the 80–90% of an organization is work from home. This is one change that has happened. The second change that has happened is that customers are increasingly moving assets to the cloud, either in a SaaS mode or in an infrastructure as a service mode. Now, with this change happening, the real question that has to be uppermost on anybody's mind is whether the old technology that we have been using traditionally for the last so many years, the IPsec VPN and the SSL VPN, is it the right kind of technology to continue with in this changed environment for securing our remote access? We believe that there is a need for change, and that is why we launched a very, very exciting company called AppGate. We think that for customers, there is a need to have a set of strategic vendors, and there is a need to have a set of tactical vendors, because if you want to win a war, you need to have strategy, you need to have tactics, and you need to have operations. So let us take a quick look at what is this whole new technology that we are talking about for securing our remote access. So let me bring in Jason here and ask him this question, because we are today governed by a lot of very interesting faces. We are hearing the word SDP, software defined perimeter. We are hearing the word SD-WAN. We are hearing zero trust access. We are hearing zero trust network access. Now, what is all this, and is there a need for this in the current environment? So this is my first question to you, Jason.
Great, thank you, Premchand, and thank you to everyone at Paramount for the opportunity to have this conversation. That was a great intro, and I think it really painted a picture of not only the changes in our industry with the shift to work from home and the adoption of SaaS and infrastructure as a service cloud, but also some of the opportunities that we have as an industry to help our organizations really make this transformation to not only becoming fully digital and becoming a lot more nimble, but to really embrace and accept this new very distributed and work from home type environment. So if we think about what's happened, you're absolutely right that organizations have been using traditional VPNs, whether they're based on IPsec or SSL, very traditional VPNs for many years. And those really hit a wall in many cases when the COVID work from home hit earlier this year. We've seen many organizations who's had to actually ration their VPN usage because it didn't have the capacity to handle all these remote users. So that's one piece of it, is just the very basic of how do I get all these newly remote workers access. The second is that those traditional VPNs impose a very strict architecture, which is a single connection from a user's device through an encrypted tunnel into an entry point to a corporate enterprise network. And then the presumption, which we think is no longer valid in today's cloud world, is that that single connection is going to be sufficient for the user to then get access to all the resources that they need. And what it does is it requires organizations to have a very complex and comprehensive enterprise network with all of these different assets available through some sort of wide area network or MPLS backbone. And that's simply not the case. Even if an organization adopts a small number of cloud-based resources, whether they're SaaS or whether they're custom applications moved up into infrastructure as a service environments, forcing all those connections to go through this single VPN provides a very poor user experience. It adds bandwidth costs, and it makes it very difficult for the organization to be nimble, and it makes it very difficult for them to be secure because they need all these things connected on the network. So all of those things taken together are really having organizations look at a new and modern architecture for approaching security and giving them the chance to think about things from what today is called zero trust, which is how do we shift our security policies and our enforcement from IP addresses and ports, and how do we shift to identities? Because that's what we all want to talk about and that we all know about. We know about people and we know about identities and roles, and we want to have policies around what they should access under what circumstances that get enforced in the right way across this network. Does that make sense, Prashant, Amit?
Yeah, Jason, in other words, what you are saying is that it is probably not the best approach for a client to backhaul his entire remote traffic to his data center, then send it through the security stack that he has already implemented, and then send it to the cloud asset. You are saying that that is probably not the right way to do it. It is better to have a direct connection between the remote user and the cloud asset. Is that your contention?
Yes, and I think we need to separate two problems that the security team is trying to solve. So the first problem is I have my employees and they're accessing resources that I don't control that are on the internet. And in those cases, you definitely want the ability to impose content filtering and data loss prevention, impose a secure web gateway on that traffic. So that makes sense to run through your security stack, as you mentioned, and that can be centralized in your headquarters or could utilize a cloud-based type of internet security service. The second use case is, how do I get my employees and partners to access resources that I do control? And in that case, there's no need to go through that security stack because you're in control of the resources and the user roles. And in those cases, you want your users to get a direct connection to wherever those resources are. If they're in headquarters, great, they can go over that connection. If they're running in a IaaS environment, they should have a connection directly up into that environment with the same level of security control, but there's no need to backhaul all that traffic to add latency and add cost.
So at a very basic level, in order to establish clear understanding, Jason, can you tell us the real difference between VPN and SDP, and how does SDP alone establish the zero trust?
Okay, I think it would be helpful to answer that question. I'm going to present a couple of slides that will talk about zero trust and will introduce the concept and the architecture behind the software-defined perimeter. And that'll, I think, answer your question and then give us the opportunity to talk about that. So I'm going to share that. All right. So I think many folks in the industry, probably everyone on the call today, has heard about this concept of zero trust. And this is a term that was actually created about 10 years ago by some analysts at Forrester Research. And it was really predicated on the principle of, let's take a step back and let's take a different approach to enterprise security, and one that has three main principles, which is one, let's make sure that all resources are secured and accessed securely, regardless of where the resources exist and who is accessing them and where they're accessing from. Let's adopt a least privilege strategy and not grant any device or any user access to the network just because they happen to be physically on the network in our building. And then let's inspect and log all the traffic. And if you think about what this does this is actually a pretty significant shift. If we think about what our normal experience is as enterprise employees, as we go into an office, we plug into the network or we get on the corporate Wi-Fi, and then we have full access to the network. And that is easy to do from an infrastructure perspective, and it's also very poor practice nowadays from a security perspective, because it's so easy for a malicious attacker to get a foothold on someone's computer through a phishing email. And that attacker then has equally broad access to all these network resources. And we've seen time and time again when these breaches happen, where attackers get a foothold on the network, they do reconnaissance, they move laterally, and then they skip across the network and ultimately steal the data that they're really looking for, or deploy ransomware and bring the organization to a halt. What Zero Trust does is it fundamentally says, even if you're in the office and you plug into a docking station on the network, you're not going to get any access to anything important until and unless you've authenticated and there's a policy that's evaluated that grants you access. And what are you going to get access to? Just those 5 or 10 things that you need to do your job and nothing else. So even if you have malware on your device, even if I accidentally clicked a phishing link, that attacker won't be able to see everything on the network. They'll be able to see the 5 or 10 business applications that I need to do my job, which is, chances are it's not the target that they're looking for. So Zero Trust as a set of principles has become very widely accepted in the industry. And over the last year, for example, the United States organization called the National Institute for Standards and Technology, or NIST, has come out with what they call Special Publication 800-207. I highly recommend that folks take a look at that. It's very readable, and it talks about Zero Trust principles and some Zero Trust architectures. Now, Zero Trust doesn't, as a concept, and even as the way that the NIST document describes it, isn't an architecture. We believe that the right architecture for achieving the goals of Zero Trust is this thing called the software-defined perimeter, and I'll talk about that for a moment. The software-defined perimeter is an open standard that was created by a nonprofit industry consortium called the Cloud Security Alliance, so it's not controlled by any vendor. And the nice thing about SDP is that it provides a flexible architecture and it fully meets the principles of Zero Trust. And then we, our company AppGate, we've built a product called AppGate SDP that is an enterprise class implementation of this. And we'll talk about how that works in a second. What the software-defined perimeter provides is fundamentally an identity-centric policy model and mechanism for enforcing access. So our customers, these enterprises, can define policies based on roles and attributes that these identities, that these users have inside their organization and inside their existing identity management system, that uses that as context and then makes access decisions very dynamically about what they should and shouldn't get access to. SDP is also fundamentally based on Zero Trust, where all assets on the network that aren't explicitly given to a user by policy are going to be hidden and inaccessible. So it really reduces the attack surface. And then finally, SDP embraces the fact, as you mentioned, Premshan, organizations really starting to use very diverse set of resources across cloud environments, across infrastructure, platform, and software as a service. And they continue to have on-premises and traditional resources. And what SDP does is it provides a single platform for defining and enforcing access control across all of those environments. And then very briefly, I'm going to walk through how the AppGate SDP product works. And the goal here is to help illustrate some of the really important concepts that SDP provides. The first to note is that the entry points to the network, made up of a controller and a gateway, are actually hidden and cloaked. They use a form of cryptography that's implemented in this thing called single packet authorization, so that unlike traditional VPNs, there is no open port, there is no server running on the internet that malicious attackers can see and do a port scan on and start to try to exploit. And unfortunately, we've seen over the last few months numerous examples of very widely deployed enterprise VPNs that suffer from these vulnerabilities and have actually had active exploits where attackers are able to get into enterprises because of this. We fundamentally believe that the open nature of TCP/IP needs to be compensated for by a security model, and SDP does that by cloaking the controllers and the gateways. So our system uses a cryptographic mechanism called single packet authorization to ensure that only properly onboarded and validated users are able to actually establish a connection, a network connection to the controller, and to authenticate the users. Users are authenticated against the organization's existing identity provider. So there's no changes required there, and organizations can get actually more value out of their identity management program and deployment. The controller acts as a zero trust policy decision point, and it makes a decision about what resources this user should get at this time, and then hands those down to the user's software in a small data token. The AppGate SDP client then utilizes that data token to make secure encrypted connections to a set of network gateways, and we're showing one of them here. And then that application on the right-hand side there is accessed through the gateway across a secure and encrypted tunnel from the user's device. Now, the nice thing about this is a very dynamic system. Unlike traditional VPNs, which once you log in, that connection stays indefinitely, AppGate SDP will look at the user's attributes, their device attributes, and overall system attributes, and make adjustments accordingly. And this is really important for cloud environments, for example, where if your developers are building or deploying new applications, let's say in a high velocity DevOps type environment, those applications on the lower right-hand side may change throughout the day, and the user's access will automatically change in an SDP environment without requiring users to sign out or sign back in. It just happens automatically. So I think there was a brief overview. We talked about zero trust principles. We talked about the software-defined perimeter architecture as an open way of approaching this. And then we talked about the mechanics of how AppGate SDP works. Does that help set the stage for the next part of our discussion from Sean and Amit?
Yes, very much, Jason. Can you just put that slide again? Just for the sake of our audience, let me ask you, is there any single point of failure here?
So there's not. The way that we've designed our implementation of the SDP architecture is to have support for high availability clusters, both on the controller as well as for the gateways. Now, this diagram, of course, just shows one instance of each for simplicity. The way that we've designed it is our controllers act as stateless servers, and customers will deploy a cluster of those, typically geographically distributed, and the gateways are deployed likewise in a cluster. Now, one of the things that's nice about this is we believe in customer choice and customer control. So these components, the controllers and the gateways, can be deployed wherever the customer wants, and all the traffic and all the networking is routed in ways that the customer decides. So if a customer wants to keep it on their enterprise or keep it in a certain country, they can do that. It's not like we're forcing them to route the traffic through a cloud that we control.
So the controller can be on-prem.
The controller can be on premises. The gateways are typically located in the enterprise environment, whether it's on premises or in a cloud environment, or more often they're in both.
And you can integrate to any of the existing authentication platform that we have.
Yes, yes. We have many customers using it with Active Directory, with LDAP-based directory servers, with SAML-based providers as well.
So in essence, what happens is that the user, once he's sort of checked by the controller, the device is authenticated, the user is authenticated, and only then he is allowed to go to that asset that he has got authorization to, and he does that through the gateway.
Exactly.
And that channel, like a VPN.
Correct. And the nice thing about this is that it actually operates transparently regardless of where the user is. So this user here, if they're accessing resources from home and they go to the office, once they can do that, their access model will be exactly the same. They'll still go through the same authorization steps. The traffic will still go through the gateways. And there might be policies that give them slightly different access if they're in the office versus remote, or maybe if they're remote, they'd be required to enter multi-factor authentication. But in general, the policy and the technology and the architecture is exactly the same. And we've seen customers that have gotten some real benefits out of this. So some of our customers who had deployed the software last year, for example, when COVID hit and they had to go 100% work from home, it almost became a non-event to them because all their users were already accessing resources in this way anyway. And even when those users were in the office, it went through the same architecture. So when those users started working from home, there was really no difference.
Okay. And can you do some form of adaptive authentication? Suppose I suddenly now do a transaction and you find the application wants a new level of authentication to be done. That can be executed on?
Yes, absolutely. The beauty of the architecture is that because the application traffic is going through the gateway has the opportunity to perform real-time, access time, authentication, and policy checks. So you could easily have a policy component that indicates if they're accessing this application here, or if the risk level goes above a certain threshold, prompt the user for a one-time password, or ask them to authenticate on their mobile device using a Face ID or something like that.
Okay. Maybe Jason, I'll come back to you after going to Amit and asking him whether his experience of having implemented in two sites. One is a small SME company, which is having a remote access now established to the Microsoft ERP, which Amit and his team did successfully. And the other is a much larger institution where 5,000 users will totally go live. I think now already 1,500 users are live. What is your experience, Amit, with the deployment? Is it as simple as we think it should be? What are the challenges?
Thanks, Ramsey. So in my experience so far, the implementation has been very smooth, especially a small organization had a different use case altogether. They were having a problem to have the remote connectivity given to their user at the right point of time. They had agents, they had a call center agent sitting outside, they have to log in on time, make sure they are able to allow to make calls only that window. These were the typical use cases. And it was pretty quick to extend this connectivity back home, and we were able to achieve that pretty well. Right? So this was one of the remote connectivity requirement, and it was just a day of job to get all those things set up done and have them connected and get into that. The other side of it was a large organization with more than 5,000 users like to connect from home. It was somewhere near to lockdown period to be started, and the biggest challenge they had was they have a multiple entity which like to connect to them, right? And they have a different way of authentication. They have different set of application to be connected in different location itself. And we were able to achieve this 5,000 user deployment scenario in just 2 days of time. And we were able to start with test cases, let them connect to the network, consume the services. And the best part was it was a very smooth transition for the end user without any hiccup or slowness or bandwidth consumption, and they were able to access this particular access. And the client, very much they liked is they are able to authenticate them separately, right? So you have one entity authenticating using AD, maybe another entity authenticating different method itself, and that gives them a leverage to control the way they wanted to do action, right? And the best part they like this, they are able to allow any connection. It can be any port and protocol they were having problem, right? So they have a soft phone connectivity like that. It was very hard to achieve with the VPN use cases, and SDP that made life very easy and flexible enough. So that was a great experience. And what personally my experience is, the moment client sees the product and uses for 2-3 days, they are able to do all their test cases themselves pretty easily and quickly. That is the beauty about this solution.
Is there a performance difference that you have noticed, Amit, between a client using an IPsec VPN or an SSL VPN vis-a-vis SDP?
The biggest problem that client have been complaining about the remote connectivity was the bandwidth utilization. And we have seen a situation where most of the banks or most of the organizations ran behind to upgrade their bandwidth, because the moment you connect VPN, you have to upscale your bandwidth requirement. The reason behind that was connecting to data center, then you're connecting to the cloud from there, or you might be connecting to a branch separately. All those traffic going via one gateway increases your bandwidth requirement. So that was one of the bottleneck, and which we were able to eliminate completely using SDP solution.
Yes, one of the one of the things that we took very seriously was the usage of bandwidth and the ability to provide very scalable performance to customers. And of course, in the diagram we showed a single gateway. What customers will typically do is deploy multiple gateways, and our approach is linearly scalable. So there's no state that's shared between the gateways, and the end users will just distribute themselves across the set of gateways. So there's not going to be any the types of limitations that enterprise customers see with traditional VPNs, which often have only a single entry point or maybe an HA pair with a cold standby. In our world, all gateways are active all the time, and if customers need more bandwidth, they can simply spin up new virtual gateways, and in 5 minutes, they'll have additional capacity.
Yeah, I think that's an important point. Amit, can you expand a little bit on what Jason mentioned about that inability for an attacker to, let's say, do lateral movement? How does this happen in the case of SDP? I'm able to access only that particular application. Let's say if I'm given access to SAP application, I will go through a secure tunnel and hit the SAP application module that I am supposed to access, and then I can't touch anything else. Is that how it is?
That's right. So in my, the simple way, if I have to say, we're able to provide connectivity with the right device, right user getting access to the right application at any point of time, right? So apart from this, you don't see anything at all. And if you cannot see anything at all, there is no way you can do a lateral movement or a brute force or DDoS kind of attack at all. So that is the concept it works in. So I can say if I'm a financial admin and I need a module of SAP application to be accessed, you get to access only that module at that point of time. Right? Anything changes around the context of the user and device, the moment it changes, your access is going to change, and you no longer see that module itself. Right? So this is how the SDP prevents this kind of attack surface and reduces a lot actually. If there's nothing can be seen, there's nothing can be attacked also. So that's the framework that we talk about.
And what is your experience, Amit, with the reporting and auditing?
All right, that's a great question. So in this case, Kibana is one of the inbuilt platforms that we have with AppGate SDP, and that really gives us the ability to create your dashboard the way you wanted to have it based on the utilization, the users, the geolocation. It's really flexible enough to create a dashboard. And if you like to integrate with your any SIEM solutions, you can definitely do that one option as well, right? So we have been asking, and there are lots of clients ask that I wanted to see who are the user connected from so country and city. There were the other way around, who are the user connecting on 445, the file transfer protocol. Right? It was really difficult to get this consolidated log in the VPN solution and many VPN solution. Here it was easy to see and you take a right action at the right time. And the other area, I think Jason may agree with this, is the monitoring of user traffic. Right? If you have something that has been trying to connect, that's not allowed, but you can see the monitoring and you can see the user behavior as well. Right? That gives admin more flexibility to see what you have been trying to connect and what kind of port protocols you're trying to connect in my network. Right? So this gives this kind of capabilities.
Yeah, we've seen because the AppGate SDP system controls the traffic from end to end, from the user's device all the way through the gateway, and because we are positively identifying and authenticating the users, we provide a very enriched stream of logs to SIEM systems. So we found that customers get tremendous benefit from these logs that give them a very clear connection or association between the identity and the resource that's being accessed. Traditional logs and traditional SIEMs often struggle to piece together this information. If we think about any complex enterprise network, what happens, of course, is that the IP addresses will change. They'll go through translation points along the way. And it's often very difficult for security teams and for SIEMs to get a clear picture of all the way over here, you've got IP address X that's accessing application Y, to actually associate that with an end user who initiated a connection across 2 or 3 network transition points. So the AppGate SDP system solves that problem and provides clear association. So it's very easy to see, oh, this is Amit Sharma, and he's accessing this application. So that's one piece. And the second piece is, as Amit mentioned, the ability to log attempts to access blocked resources. So that's very easy to do. It's very easy to set up mechanisms inside AppGate SDP to log and alert on that. And it's actually very easy to set up honeypots as well, where if anyone ever goes to them, you would know that it's either a malicious user or malicious activity because there's no business application attached to it.
Jason, can you throw some light on what is happening in Europe and US in terms of what kind of use cases are ensuring the deployment of this technology? What kind of environments are adopting this technology?
Sure thing. There are several ones that we see as very common ways for organizations to get started with AppGate SDP. And today, the number one is really around remote access. Of course, everyone has gone through the initial phases of COVID-19 work from home, and they've often struggled with using whatever they happen to have in place. And now that they've gotten over that first phase, they can take a step back and say, all right, my VPN is really a problem, and it's got poor user experience and poor performance, and it's making me pay a lot of money for this MPLS backbone. So I want to shift to a more distributed model. And we're having a lot of customers and enterprises who come to us and look at, how do I replace my VPN? How do I save money by getting rid of all this network infrastructure that I don't need anymore and get my remote users with this kind of secure access? That's a really common way to get started because it's a relatively simple problem and there are very clear business and security benefits. A second common use case is around one of the trends that you mentioned, Premshan, which is cloud adoption. As organizations move their workloads and their custom applications that really run their business from traditional on-premises up into infrastructure or platform as a service environments, they need ways for their developers and their end users, their employees, and even their partners, customers, to get access to that. That transition can take the form of taking on-premises applications, virtualizing them, and moving them up to the cloud, or it can take a much more, I would say, exciting and innovative approach where they reinvent these applications and start using some of the capabilities in those cloud environments. In both cases, the security model is very different than traditional on-premises security, and it really calls for a modern identity and dynamic approach like SDP. So that's a very common, that's another very common use case.
So going forward, Jason, what is your personal viewpoint on this particular aspect? Will SDP coexist with CASB and SD-WAN? Do you think that is the way the industry will move?
I think that there's really two things that organizations are adopting. One is CASB, as you mentioned, and the building out of those technologies, security technologies, to help organizations drive their internet-bound traffic through a service like that, so it can be controlled and managed, and you can do things like DLP and anti-malware. It's really important because there's a lot of bad things out on the internet. The second is enterprise networks, and we think that the usage of traditional enterprise backbones, whether it's things like MPLS and even SD-WAN, are probably going to become less important over time. And we've seen customers save tremendous amounts of money, hundreds of thousands of dollars, if not more, every year by reducing the MPLS and switching to just very basic internet service provider connectivity from their offices. So they no longer need a special circuit, and they no longer need even the additional services around, let's say, qualities of service that some SD-WAN providers have. We think that if you think about where we're going with ubiquitous connectivity, whether it's wireline based to our offices or in the very near future cellular and 5G based, we're just going to assume that connectivity is reliable and there, and we have to worry about securing it. And I think that's going to be the shift, is how do we build a dynamic policy model that lets our users and our devices and our sensors connect securely and not worry about provisioning the infrastructure ourselves.
Very important. And Jason, what are our analyst friends, the Forresters and the Gartners of this world? What are they saying about this particular space and the rate of adoption?
They're seeing it accelerate for certain, both both the major industry analysts, the Gartners and the Forresters of the world, as well as the more boutique analyst firms, are talking about this trend. And they all recognize that we have a tremendous amount of security technology out there. That's not the problem. In fact, maybe that is the problem. The problem is the complexity of managing it. That is really what most organizations are struggling with. And the benefits of utilizing an architecture like SDP is that it provides a normalizing layer across all of this, where now you can define a single access control model and a single platform that will automatically control access across on-premises and remote users and resources that are in your office and your data center and your cloud environments. It reduces the complexity, which is the biggest barrier to security in many organizations.
I think one of the simplest areas, Amit, where particularly in this region, where the deployment is likely to happen is with the small and medium enterprises, where all of them have got a critical ERP running in a data center. And that ERP is unlikely to move to the cloud in the near term. So it will continue to be in the data center. And that ERP, if it is to be accessed remotely, I think the easiest way to do it securely is through the implementation of an SDP, because there is simplicity in the implementation, there is simplicity and ease in the support. What is your opinion?
Yes, sir. So the basic thing, the most of the SME have problem is connecting with the multiple location, and they have to punch in gateway in each and every site. It's not convenience for the users, right? So you have to connect to one location, you connect to another location, and it's really complicated for them. And as they're slowly moving to cloud adoption, they might be having a hybrid for some time, and handling multiple solutions and disconnecting, connecting doesn't give a great experience to the user as well. So SDP really adds value here. It's a single window where you are able to connect on-prem, maybe multiple sites, and at the same point of time, you are connected to the cloud infrastructure as well in your cloud journey itself. On top of this, you can think of all those easy access based on the compliance or the MFA and all the security context around this before you give access to someone. At any given point of time, we have a full control to see who access, when access, what access, and all those things around that. It's really a great experience to the user.
Very important. I think, Sushan, what do you think? Have we been able to communicate to our audience the benefits of adopting this technology, the manner in which this works, and why we think that going forward, this is something that they should definitely experiment? Should we take some questions from the audience?
Yes, sir, definitely. There are actually a few questions that we have. So I'll just go for the first one. How can SDP complement the VDI infrastructure? What is the need of having an SDP?
Excellent. Who wants to take this? Jason?
Sure. So VDI, of course, is a very widespread technology that's helped organizations centralize control and management of these desktops. And we've seen customers utilize SDP with VDI in a couple of ways. In one case, what organizations will do is they will deploy the SDP client inside these virtualized desktop environments, so that when a user logs in and gets a virtual desktop, the AppGate SDP client will be running in that environment and will provide them with the same sort of access control as if it were running on a physical server. So the same sort of identity-centric policies apply. And that's a nice way of having your VDI server, which of course needs pretty broad network access, but making sure that each individual user only gets the access they need. So that's a very common approach. Another approach would be actually to put the SDP controller and gateway in front of the VDI server rather than exposing that to the internet. And that would be a different type of use case where users would typically just be working on that desktop directly and not using that as a jumping point to get inside the organization. So that's a common way to do it. In some cases, organizations realize that if they're only using their VDI as a jump box or a launch pad to get to resources inside the enterprise, they can simply, in some cases, bypass it by having the user run the AppGate SDP client on their device, even if it's a BYOD, do the type of device posture check and security confirmation that they need, and then have the users access the resources that way. So there's a lot of trade-offs here, but in all cases, there's some real value about bringing this type of security model into a VDI environment.
Okay. The next question is, how does SDP add value for an IoT OT environment?
Okay, so the question is around IoT and OT, and we really look at this as those are really interesting devices, and those devices can be something like sensors, they can be operational technology that's managing industrial control systems, but there's other type of enterprise devices that also fall into the same category, whether they're VoIP phones or printers or IP cameras. And what all those devices have in common is that they're closed systems. They're not running Windows or Mac OS or iOS. You can't have the enterprise install software on them. So we've extended the SDP architecture to support a component that we call a controller. And I didn't, excuse me, a connector. We didn't show the connector in the diagram, but it acts as a network concentrator, if you will, and allows devices like printers and VoIP phones and IoT devices to route their traffic up through the connector. And then the connector will be enforcing policies as that traffic goes up through a gateway and into the enterprise network. And the nice thing about our system, the way we designed our policy model, is we actually support bidirectional policies, bidirectional communications. So you might have a sensor that is generating data and needs to push it through a gateway up to a server in your data center. And you might have an administrator or a third party who needs to connect down to that sensor to log into it and maybe update the software or update the firmware on that. So our policy model allows for both of those in this very flexible type of deployment using this connector component.
The next one, what is the level of granularity control we are expecting from SDP?
The nice thing about the policy model that we've designed is, number one, it's very flexible, and number two, it's very dynamic. So some organizations might start off and provide very broad network access just to mimic the access that users get from the VPN. And they would do that because maybe they don't know exactly what resources users are getting to. So they would grant a policy that gives everyone access to the full subnet. That's a perfectly fine way to get started. It's not a good place to finish, right? The policy model that we recommend would utilize either identification of specific hosts, maybe by host name, or by dynamically discovering resources. And that's really where the system gets very powerful, where you can have components in the AppGate SDP system that will make API calls and query configuration management database, or do DNS lookups, or query metadata in a cloud environment, or even query the status of business processes like a service desk status. All those things can be pulled in and be made part of a policy model so that users only get access to resources that match certain, let's say, tags in an infrastructure environment, or only get access to resources that have an open service desk ticket indicating there's a problem that needs to be fixed on this server, and you as an IT admin have to go fix that. So there's a high degree of precision and a high degree of dynamic capabilities that we see customers really take advantage of. And the power comes in the ability to tie this into metadata and tie this into business processes so that users are completely productive and the system is maximally secure.
Okay.
There's an interesting question. Access. He's saying that only for a defined period of time to my third parties can I give that access.
Yes. Yes. The nice thing about these policies is that they're context sensitive, and the context that they rely on is something that is very easily extensible. We built our system with a high degree of APIs, both inbound and outbound APIs. So you could very easily have a system that grants third parties access, but have that be dependent on a service desk ticket. So you could very easily open a service desk ticket that says, okay, it's now this time of day or this day of week, and there's a problem that my third party needs to access. So all of those attributes or those conditions could be applied to a policy to only allow access during certain time periods, or if there's a business process that's been followed.
Okay. There's another very interesting question, and that is, we've seen many vendors offering SDP. How does AppGate, how is it different from your competitors? I think before I ask Jason to answer this question, for the benefit of our audience, let me tell you that we looked at the SDP technology because we were convinced that from a simplicity standpoint, this is probably the best way to ensure remote secure access to an asset which is either on-prem or in the cloud. We felt that simplicity was the most beneficial part of an SDP. So we looked at SDP almost 2 years ago. And we looked at various companies. We looked at a company called Sixtera. We looked at a company called Perimeter 81 from Israel. We looked at what Zscaler was having. We looked at 2 other companies. So out of all the evaluation that we did technically, we felt that AppGate was the best product to go in with. One of the technical reasons was the fact that you could have the controller on-prem. In most other solutions, you cannot have the controller on-prem. And in this region, we found that many customers were insisting that they must have the controller on-prem and not in the cloud. And we feel that going forward, even when you move your assets to the cloud, there will be a tendency on your part to continue with several assets on-prem. And therefore, this need will continue to exist at least in the near term. This was one of the primary reasons from a technical standpoint. The rest, of course, I think I'll leave it to both Jason and Amit to answer. Jason, you come in first.
Very good, thank you. There are definitely a lot of vendors who claim to provide a software-defined perimeter architecture, and we would encourage folks to take a look at the advantages and disadvantages of the way that they approach things. As Premchand mentioned, we really believe in customer choice and believe that customers need to have the ability to decide where to put the controller and where to deploy the gateways so that they're in control of their network traffic, and that we don't require enterprises, customers, to route their traffic up through a cloud that's outside of their control. So that's one piece of the architecture and the way that we believe that our product is at least the best in the market. Second is around scalability and performance. We touched on this earlier, but we really architected the product to be very high performance with somewhere between 5 and 20 times the typical throughput versus a traditional VPN on commodity hardware or on typical virtual environments. So enterprises don't have any issue with the type of performance issues that traditional remote access solutions have in place. And then finally, and probably most importantly, is the type of network protocol support and the dynamic ability to adjust and detect user access we think is really unprecedented. So some of the examples I gave around tying access for a business process or looking at metadata tags in the cloud environment, we think there's no other product that can help organizations get that kind of dynamic access control in an automated fashion. So you're simplifying things while streamlining them at the same time. Amit?
Yeah.
What is your practical viewpoint? You were the one who did multiple evaluations as well as implemented for multiple clients and also implemented for us.
Yes. So one of the biggest thing that we found compared to the other product was most of them work in a traditional way where the controllers are in their control and none of them exist in the GCC region. So you have to have go somewhere else and connect back to your own resource back to UAE or nearest to your data center. The second was most of them were working a reverse proxy method. All the way traffic goes back to you and then is connecting back to you, and some places they charge for the data transaction as well. Right. So these are the two difference makers we have found, and out of this, my data is always going to my gateway, which is in my control. Let it be on a cloud, let it be an on-prem. That adds a great benefit to the control at any time. We are not loading my bandwidth by doing a reverse proxy, somewhere going to Europe or somewhere else and then coming back to me, which adds to latency over here. That is not the case here, and that's the reason we have a great performance in terms of compared to any other technology that personally I have evaluated so far. So these are the two areas that I found really interesting, and it's easy to have any potent protocol was one of my key areas to look into, right? So one of the area, the other we're failing is they have a limited control on the port and protocol that they support. In this case, I have no problem at all. I can route any kind of traffic back to anywhere my service is going. That gives a great flexibility. That's all from my side.
Okay, we have
continuity also. I think you were very impressed with the way the whole IT continuity works for SDP.
Yeah, these are one of the way we had, and the deployment was pretty simple. So we don't need much time to deploy things here and there. So easiness, you fire up only one image which handles your controller, gateway, and the log server role. We are not deploying multiple server. We don't need a dedicated hardware. We don't need a dedicated OS from the client. So these are all the easy that client fills up. Just put it up, have the right role given, integrate with your area or whatever the IDP source we have, and we are good to go. And the POC cases, the initial test cases were less than 2 to 3 hours of work, and we were able to start with the POC and the use cases. That's the easiness we had. And the best thing about this product was the moment client gets the console of the product, in a day or 2 days of time, the client starts building things from this, themselves. That was the beauty of this product. Personally, I was convinced with that way. And that's, we didn't see any support calls. We're not getting any query or complaints so often in this area. Compared to other technology, if you ask me, we have been getting lots of query that this is not working, integration is not happening, there is a bug, things around that. That was not the case over in this particular solution.
okay.
Also,
There is one.
Reporting. Since the Kibana is being used, there is a lot of flexibility and excellent reports are possible.
That's right. So that's right. So we were able to customize the dashboard. One of the biggest challenges was if I had to look back 1 month log, it's always the IP we look at. In this case, I have a complete control to see who connected, how frequently he connected, and things around all those identities that we're talking about. Right? So that's adds, and it's pretty much flexible. You have all the data, all the logs. You can create your own showcase, you can have a right action taken. All those things were pretty much possible in this scenario. Right? So yeah, that gives a good control. You are not depending on any third-party solution. The SME client may not have a SIM solution to have a dashboard for this kind of requirement. In this case, we are able to build dashboard day one. Once you connect your, the dynamic dashboards get started, and you can add in your dashboard as you need. So that was the benefit that client had seen in terms of the dashboard capability. Jason, you like to add anything over here?
Yeah, there is one more very interesting question. Is there anything that SDP cannot do for which a customer may still need to rely on a VPN solution?
Just you like to take over?
Yeah. Remember, of course, that when we talk about VPNs, there are enterprise VPNs focused on remote access for users. And in that case, we've never seen an example of a VPN that can't be replaced and improved by SDP. Our customers are using our product for every type of network protocol, whether it's TCP or UDP or even ICMP and some other protocols on top of that, and for connections and communications in both directions. The type of performance that we provide makes it suitable as well for streaming, video conferences like this one. So in that case, the answer is no. There's no instance where it couldn't technically be done and where there's not going to be benefits that are obtained. Of course, there's other types of VPNs, like a site-to-site VPN, and depending on those situations, it may or may not make sense to replace those. I think it really depends on the details of the volume and the type of traffic and what the network topology looks like.
Okay, one last question. You have mentioned about VoIP users. How easy is it to integrate?
It's very straightforward. Remember, all you would do is model in the policy what the network communication looks like. So you've got probably, for most VoIP systems, you've got some traffic that is going to be initiated from the user's device up to a VoIP server, and then there's probably going to be a set of UDP-based traffic that comes initiated from the VoIP server down to the user's device. So it's simply a question of looking at where does the source IP address go, where does it go in the user's device, and set up a policy that permits network to go in both directions.
Yeah.
Okay, I think that's about the questions that we have now.
I have to bring up one of the use cases the client has the biggest problem in the COVID situation was they have a workforce working from home, and just to reset the password, they have to come to office to just join to domain and reset the password. One of the biggest problems the client had. We were able to read the LDAP parameters saying that your password is about to expire. We prompt user and you do Control-Alt-Del from a home when your password is changed. You don't have to go to office at all. Now think of a workforce with 1,000, 2,000 users and in password policy for 60 days or 90 days, you have to visit office in this situation. Maybe possibility that most of the user password expiring in a single day. How do you handle that job was one of the biggest challenge for the client. We were able to do those use cases as well. One of the client has a issue that they have image, the image was loaded to the device, but they couldn't join to the domain because users are working from home. We were able to provide flexibility and you join to domain sitting at home as well. That was one of the best use cases the client have seen actually. That VPN is really not possible, and if you do this, you wide open your ports, which is very much risky for you.
Yeah, that's actually a very common use case, which is the restriction of being on the same local area network as the domain controller. And AppGate SDP has some very nice capabilities that actually we're using ourselves internally, and a lot of our customers are using as well in exactly the example you gave them, which is the ability to have this connect to these corporate resources across the secure tunnel even before a user logs in, so that they're virtually on the network and they can do things like domain join their machine or reset their password without having to physically travel to an office.
I think that's all the questions we have for today.
So in conclusion, let me just tell our audience what I personally believe. It was in the year 2002, I think, that we launched the first SSL VPN in the market. At that time, there was only IPsec VPN. And I found it very difficult initially to get customers to accept SSL VPN because everybody was comfortable with the IPsec VPN. But if you look at the reality today, even after 20 years, we are all using the same IPsec VPN and SSL VPN technology, and everything around us has changed. The work from home is an absolute reality today, and assets in the cloud is another new reality, both of which didn't exist in the early 2000s. I think, therefore, it is very imperative that you seriously look at this technology, evaluate it in your environment, see if it works to your benefit, and have it implemented. I'm certain that you will find benefit in this. It's a very, very simple and useful technology. So good luck to all of you. So thank you very much, Jason. Thank you, Amit. Thank you all for attending.
Thank you. Thank you, everyone. Have a great day.
Thank you.
Take care. Bye-bye.